The question says an AM DSB-FC transmitter, that means AM double sideband full carrier transmitter, with unmodulated carrier power of 18 watts. So carrier power PC is given as 18 watts. When I say it is unmodulated carrier power, that means it is the power of the original carrier signal which is present before modulation. The question says this carrier is modulated simultaneously by three modulating signals with modulation coefficients of M1 equal to 0.2, M2 equal to 0.4, and M3 equal to 0.5. They have given individual modulation indices. This is the case because there are three modulating frequencies which are modulating the carrier, FM1, FM2 and FM3. And we are given modulation indices of all the three frequencies individually. The question is find total modulation index, total M, and we have to find out power in upper sideband and power in lower sideband of the overall signal which is generated, and finally we have to find out the total power. So let's discuss this question, everyone. Whenever there are multiple modulation indices given, the carrier power given as 100 watts. This is the carrier power mentioned in the question. So when we find out the overall modulation index, now the overall modulation index M is related to individual modulation indices as M square is M1 square plus M2 square plus M3 square. This is the formula that we had discussed before under multitone modulation of the carrier signal. That means the modulation with multiple modulating frequencies. So if I want to find the overall value of M, it is always square root of sum of squares of individual modulation indices. And therefore, the overall modulation index will become under root 0.2 square plus 0.4 square plus 0.5 square. And this will come out to be equal to approximately 0.67. So that's the answer to the first question that we have got. Next, we have to find out power in upper sideband and lower sideband, and then find out the total power also. So I can find out power in upper sideband and lower sideband, P LSB and P USB. Now once again referring to one of the clips that we have had previously in which we had discussed the power calculations, upper and lower sideband power is given as M square into PC by 4, where PC is nothing but the carrier power. Whatever M that we use here has to be overall M. In this case, this overall M is nothing but 0.67. So 0.67 into PC is 100, and this will be divided by 4. So if you work this out, the upper and lower sideband power both will be of equal value, comes out to be 11.25 watts. So in case they had asked the total sideband power, the total sideband power is always the sum of lower sideband power and upper sideband power. And in this case, if you add or simply twice 11.25, you get 22.5. That's the total power in both the sidebands combined. And finally, we have to find the total power in the modulated signal, which is PT. You can find total power using formula PC plus PSB. That means the power in carrier and total power in both the sidebands. This will be 100 plus 22.5. And this will come out to be equal to 122.5 watts. Alternatively, we can also use the total power formula in the form of carrier power, which is PC into 1 plus M square by 2. And this will be nothing but PC into 1 plus. Again, this M has to be the overall M, 0.67 square by 2. And the value of PC given as 100 watts. And therefore the total power, if you find by this formula, also comes out to be 122.5 watts. So that's all the three questions answered which we had in the given problem.